Hallo, it's Dumplet here. Here's an item on algebra. Let P, Q, R, and S be the roots to the following quartic equation: x to the fourth plus 4x cubed plus 8x squared plus x minus 2022 is equal to 0. Find the value of the expression in red. Now this question came from Dan of 2022, an exam that Dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Alright, let's take a look at the given equation, and let's try to compare it with the thing we're getting, because items like these, chances are we have to use either Vietas or just some algebraic manipulation followed by Vietas, because Vieta's relation don't give us anything in terms of like to the fourth power, so probably you have to manipulate a little bit before we can proceed and to use Vietas. Now let's try to take a look here. We're getting the fourth powers of the root plus 1, so it's of this format, so root plus 1, root plus 1, root plus 1, root plus 1, then we're raising it to the fourth power, so there might be something involved with x plus 1 raised to the fourth power. Now in fact, if you go visit the Pascal's triangle, with the convention that the first row is going to be the 0th row, so the 0th row will be the 1. If we try to visit the fourth row, we're going to see that it's going to be 1, 4, 6, 4, 1. It's pretty nice we have the 1 and 4 here, so we could try to manipulate it to kind of look like we're trying to manipulate it so that it's going to be like this, because we know that, well, if I expand x plus 1 raised to the fourth, now that I know that the coefficient is 1, 4, 6, 4, 1. It's going to be x to the fourth plus 4x cubed plus 6x squared plus 4x plus 1, right? So technically speaking, this has a coefficient of 1. Then the 4, 6, 4, and 1 will follow like this. Okay, so let's try to rewrite this the left-hand side of the given quartic equation. Let's write the x plus 1 raised to the fourth first, the x plus 1 raised to the fourth. And let's try to see what's missing here, because the x to the fourth, that's matching, the 4x cubed, that's matching, but we only have 6x squared so far, and we want an 8x squared, so I think what we have to do, we add an additional 2x squared, right? Now we have 4x, but we only need x, so we could subtract the 3x, and then we have 1, but we need negative 2022, so we could subtract 2023, right? I just manipulated. So bring in a x plus 1 to the fourth, and then I just kind of added and subtracted the sum of the terms so that it's going to be the same. So I didn't change the left hand side. I just wrote it in such a way that I will have something in terms of like x plus 1 to the fourth. The reason why I wanted to do that is because I can have x plus 1 to the fourth being equal to, let me just write this down. So let me put these three terms on the other side. So 2023 plus 3x minus 2x squared. All right, so we have so far this. So x plus 1 to the fourth is equal to 2023 plus 3x minus 2x squared. Now, obviously, this is just the same as the original quartic equation. I just manipulated it. So P, Q, R, and S should satisfy this equation, which means I can have P plus 1 to the fourth. That's going to be 2023 plus 3P minus 2P squared. And obviously I could do it for the Q. So Q plus 1 to the fourth is 2023 plus 3Q minus 2Q squared. And you guys can see where am I going here. I could do the same with R and S, and I would get the same thing. So 2023 plus 3 times the root minus 2 times square of the root. And that's going to be true for all of these four. So P, Q, R, and S. All right. So it should be S here. So S. Okay. And take a look here. We have the fourth powers of 1 more than the root. So apparently we have to add both sides of these four equations. So I'm just going to call the sum of these four as S. So this is the sum that we want. So S will be equal to, four 2023s. That's going to give us 8,092. And then 3P plus 3Q plus 3R plus 3S. We could factor the 3 out. So it's going to be plus P plus Q plus R plus S. And then minus 2p squared minus 2q squared minus 2r squared minus 2s squared. I could factor a negative 2 here, so minus 2. and then the sum of the squares, p squared, q squared, r squared, and s squared. Now, apparently to know what s is, so to know what s is, I just have to get these two values, right? Now let's go back to the original equation, because these two expressions are easy to get with Vieta's relations. So let's try to have it here. So far we just have to get p plus q plus r plus s and this one, right? Now by Vieta's relations, the sum of the roots, it's going to be the negative b over a. It's going to be negative 4. So this b is 4 divided by coefficient, which is a, so negative 4 over 1. Well, that's just equal to negative 4. And then, right, so this part is apparently just negative 4. And then for the sum of the squares, we have this nice identity that the sum of the squares, so p squared plus q squared plus r squared plus s squared, we can write this as p plus q plus r plus s, so the square of this one, minus 2 times pq plus pr plus ps, so the sum of the roots taken 2 at a time, so covering all possible pairings of the roots. Okay, so p plus q plus r plus s, that's already given, it's just the same as this one, so that's negative 4. But for the pq plus pr plus ps plus rs plus ps plus pr, so all possible pairings across the roots, that's going to be the value c over a. So it's going to be 8, that's the value of c, so 8 over 1. So by Vieta's relations, this green part will be equal to 8. All right, so we could try to expand this now. So 8092 is just 8092 plus 3 times p plus q plus r plus s, that's negative 4, and then minus 2 times, now we know that it's going to be p plus q plus r plus s squared, so negative 4 squared, and then, well, the green part is 8, so minus 2 times 8. So 3 times negative 4, so that's essentially minus 12. And then, well, the square of negative 4 is 16. 2 times 8 is 16. So, well, this term is just going to go away because 16 minus 16 is 0. So essentially, we just have 8092 minus 12. So 8092 minus 12, that's going to give us 8080 as our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.